It's about time we make use of my overkill server here. A few months ago, I did a video on the 64-core EPYC system from ASRock and essentially deemed it was too powerful for my lab. So of course I boxed it up and sent it back to ASRock, right? Right? Absolutely not. With the help of this video sponsor, Solidigm, I've not only added high-speed networking and a GPU for AI workloads, but I've also got 182 terabytes of NVMe storage to put in here. This is insane. Let's get into it. Okay, here's the thing. I've already deemed this server way overkill for my lab, and that's a sentiment shared by 99% of home labbers, but what's the point of having a YouTube channel if not to justify doing obnoxious stuff? This server already comes loaded with an AMD EPYC 9534, which is a 64-core 128-thread monster of a CPU, which alone is enough to run the entirety of my lab, no joke. And since we have 128 lanes of PCIe Gen 5, we get 12 U.3 NVMe slots, 2 PCIe X16 slots, and room for an OCP3 card. It's a beast. However, as you'll notice, it's a thin boy, which means I was limited as to what GPUs I could put in here since it has to be a single slot card that's half length. There's already not a ton of options out there, especially if you don't want to spend like $1 zillion, and yes, I get the irony here. My plan was to get a decently powerful enough GPU with enough VRAM to split up between AI workloads and distribution to other VMs for transcoding or gaming. This led me to the NVIDIA Tesla T4, a low-power GPU with 16 gigs of VRAM. Yes, it's far from the hot new GPU on the block with a 2018 release date, but for $400, I don't know that there's a better deal out there for my use case. The next thing I wanted to add was proper high-speed networking. I have a few 100 gig NICs sitting around, which would have been good, but I wanted to make use of this OCP3 slot. This is basically a fancy standard manufacturers came up with to upgrade networking on servers over PCIe. My guess is that has something to do with the hot swappable nature of these things. Now, since I'm a cheap asshole and only have overkill stuff because it was sent to me, I only bought the dual port 25 gig card. Turns out these aren't cheap, and I couldn't justify having another 100 gig card sitting around after ASRock makes me send the server back. It was like $150, which isn't cheap, but that's a drop in the bucket compared to the next edition. Up here in the front, we have 182 terabytes of U.2 NVMe storage with a total retail value of $25,000. Yeah, you heard that right. 7 drives are worth more than 2 of these entire servers. They're worth more than anything in my entire lab, honestly. Hell, they're worth more than a brand new Toyota Corolla. So it's no surprise that I obviously didn't buy those. Solidigm sent them over for the video. No, I don't get to keep them unless you comment, wow, Solidigm is my favorite dime. That was in the contract. What we have here are two 15.36 terabyte D7 P5520s and 5 30.72 terabyte D5 P5316s. So yeah, roughly 180 terabytes of NVMe storage, no big deal. These things are designed for data centers and serious workloads where high capacity and high speed is a necessity. These are the drives that power some of the most important systems in the world, and I'll be using them to watch Married with Children on Plex. In reality, there aren't many workloads in the home lab that can take advantage of these, but that doesn't mean they're not cool. The P5520s are PCIe Gen 4 TLC drives that idle at 5 watts, can do reads up to 1 million IOPS, and has a write endurance of 28 petabytes. The P5316s are similar in that they're Gen 4 drives, but they're QLC, so clearly designed for higher capacity with a slight hit to the speed and write endurance, but still comically high. Now that's the hardware we'll be using, and if you want to know more about the server itself, go watch my video on it. Oh yeah, we have 192 gigs of RAM in here. So let's dive into the fun part, the software. The obvious choice for me is Proxmox, because that's just what I like. Maybe you like Hannah Montana OS. That's cool too. The first thing I wanted to do was test out these drives because I've never seen anything like this, except for the last time I showed off this server, but that's besides the point. In terms of random write tests, you can clearly see that our P5520s are designed for these workloads with 700,000 IOPS, which is basically how fast you can write a crap ton of small files, so logging, databases, I don't know, probably AI shit. Basically, 700,000 is pretty dang good. Now we move on to sequential reads and writes. these guys are still fast, like 7 GB per second fast. And the writes aren't no slouch either. Yeah, that's cool and all, but you're probably saying,
Brett, I bought an NVMe drive off Amazon that can do that too.
yeah, I mean, you probably did, but how about we take those 30 terabyte drives, all 5 of them, and RAID 0 them together? Yeah, roughly 150 terabytes of raw storage striped together. Can you do that with your Amazon drives? I mean, maybe if you're an absolute mad lad, but you're not gonna do that. So here we are now with a massive amount of high-speed storage with a comical amount of bandwidth. I mean, look at this. That's 34 gigabytes per second reads and 14 gigabyte per second writes on a 150 terabyte pool. Who needs that? Certainly not me, and probably not you, let's be honest. These are for enterprise customers who are running massive workloads that need 2 things, high capacity and high speed. Us consumers usually only need one of those things at a time. High speed, but not so much capacity for like boot drives and to run VMs, and high capacity, but not so much speed for raw storage. Another thing about these drives is that they take up less space and don't require a bunch of power to spin them up since there's no spinning. That's an actual legitimate concern of a lot of massive HDD systems where they have to stagger the spin up of the drives because doing all of them at the same time would draw too much power. So now you're understanding why those exist, right? So what am I going to use them for? Well, probably hosting VMs and making a comically fast / compact mass storage setup for Plex video soon. On a serious note, I have no real workloads that will utilize those drives, and that's fine because they're loaners anyway, so they're going back to Solidom. But if you're one of those people who's looking for high capacity, high speed storage and have the cash for it, Solidom's where it's at. Moving on from our comical storage setup, let's talk about the other 2 more grounded upgrades. First, we'll talk about the networking. Now there isn't too much going on here in terms of software. With a dual port 25 gig NIC, we can get 25 gigabit per second to a single client, or if we do lag, we can get 50 gigabit total. That's 3.125 gigabyte and 6.250 gigabyte per second respectively. And those numbers are pretty close to the speeds of our individual drives we were just talking about for reference. Obviously, it's not anything earth-shattering. Hell, I have a 100 gig NIC in my main editing PC, but if the plan is to utilize these drives to at least some of their potential, I'd like to at least be able to access them from other systems faster than the built-in 10 gig connection. Saying that out loud sounds so ridiculous. Another reason why I chose this NIC, and specifically the dual port version, is that I'm testing out a cool feature called MC-Lag, or multi-chassis link aggregation, with my new 100 gig UniFi switches, so stay tuned for a video on that. Basically, it allows you to connect a single client to 2 separate switches and have what would be considered a single highly available connection. It's pretty neat. I did just see something on my feed about NVIDIA's new ConnectX card being an 800 gig model. Like, bro, that's insane. 800 gigabit per second is like 100 gigabytes per second. That's insane. That's more than the max speeds of all these drives in RAID 0. So honestly, 25 gig probably isn't too overkill depending on what your use case is. And now for the GPU buzzword update. I mean GPU AI update. I personally run a local AI instance in my home lab because it's a fun tool to play with, and I actually use it pretty often for small coding questions. My personal go-to attack is Ollama with OpenWebUI using Docker, and it works great. The NVIDIA Tesla T4 is a solid little card for this, but I didn't want to just dedicate this entire card to an AI instance that I only use every once in a while, so I split it in half. Not literally. Since this is a vGPU supported card, I can use NVIDIA's software to split this GPU into multiple virtual GPUs. The stipulation is that all the vGPUs have to have the same amount of VRAM, so with a 16 gigabyte card, I could do 16 1 gig, 8 2 gig, or 4 gig vGPUs, and I went with 2 8 gig ones where one could be dedicated to the AI instance and one could be passed through to a Windows VM for cloud gaming. Honestly, the T4 is decent enough for some 1080p gaming, which is way better than nothing. Remember, this is only a 70 watt card. For the other half of the card, I spin up my AI stack using Docker Compose, which basically spins up Ollama, which is the actual AI setup that is going to leverage your GPU, and OpenWebUI, which is the GUI that makes it way easier to interact with your AI instance. OpenWebUI isn't perfect, but for a free piece of software in this wild, wild west of AI products, solid. Once you create an account and log in, you can go into your settings, and assuming you use the Docker Compose setup, your Llama AI instance should be linked. But if you're hosting it somewhere else, then make sure you specify that here. Then you can select from the many different models in the Ollama model library, which makes it impressively easy to get started. Because all you do is hit download and you have it. You can also bring your own, but I don't need to do all that. From there, your model is available to use on the main page, and you can begin forming a weird parasocial relationship with your server. Or, just ask it to do funny stuff and never use it again. Totally up to you. If we take a look at the NVIDIA SMI while we're using the model, we can see why these AI-focused GPUs have so much VRAM, because a single small model can take about 3 to 6 gigabytes. I'd say for the price, the Tesla T4 is a solid card if you're looking to do something similar. So yeah, we now have an even more overkill server being heavily underutilized in my home lab. Please, I'm begging you, give me some tangible workloads you'd like to see me run on here so I can justify having this thing. Maybe I can throw another GPU in here and make an insane cloud gaming server. I could do 8 systems where each VM gets their own 16 threads, 24 gigs of RAM, and 20 terabytes of NVMe storage. I don't know, man. But if you like this video, like and subscribe so you'll be around for some future videos I have cooking up. I want to give a huge shout out to my YouTube members and my Patreons. You guys are my RAID 0 NVMe setup with the most IOPS I've ever seen. Y'all are fast. And if you're still watching, you're SATA. Thank you so much, and I'll see you in the next one.